Hey guys, welcome back to the garage. In this video, I'm going to bench test this new motor that the customer provided for the lathe. Okay, it's an Italian-made motor. It's a half horsepower and it draws 1.8 amps. It's a metric motor and it should fit the machine really well. The original pulley fits the shaft okay, so that's good. Just saves some work, but it's a three-phase motor where the other one was a single-phase motor. So this will allow the use of a variable frequency drive. We bought this one from Automation Direct. It is the GS1 10P5 120 volt input with a half horsepower output. That's right, it takes 120 volt single phase and it will output 220 volt three phase and give us variable speed for this motor. So let's go ahead and unbox this manual. It's a very tiny drive, so that's a good thing. There's the drive. I think it's about 5 inches by 5 inches by maybe 2.5 inches wide. Line goes up at the top, line 1, line 2, line 3. Of course we're using single phase, so we'll only have line 1. And it has 4 digital inputs. We'll be using digital input 1 for forward, digital input 2 for reverse, and we'll likely use digital input 3 for a reset. And it's got analog input, and then this, I believe this is common here. We've got the manual, we'll be double checking it. And it has a relay output, and this relay output we'll use for fault with the variable frequency drive. It will stop the CNC software and put a message on the display that there is a spindle fault. Here's the cover for the motor, and it has a little schematic, or basically I should say it's got a tap chart. Okay, if we were using 460 volts, the shorting bars would be going up and no shorting bar across, but we're using 220 volt. So there's a shorting bar going across the top 3, so the motor is already preset for that. And then the shorting bars go across these pairs of terminals and it's already set up. So it's already set up for 220 volt. This little tag, in America and the USA, these are usually stuck on the inside, so we'll leave this tag here. Not that anybody's going to be changing the voltage, but this is the cover anyway for the motor. It goes something like that. Now the one thing that I noticed about this cover and this motor, Italian-made motor, there's no provision on the inside of the compartment for a ground. So, and that's important. We want to ground the frame of this motor. So the ground is external. So basically, how do you get the cable in and then get a ground out? Well, you do one of two things. You can run an external wire along with the motor cable back to the cabinet. Or in my case, what I did is I've already got my cable in there, is I drilled a small hole here, just the diameter of the wire to come out. So when the cover is installed, I have enough pigtail wire here to make it to the ground lug, so that's the plan. Again, most motors in the US, the ground is on the inside of the terminal compartment. The other thing I wanted to show you guys on this cable, it's a VFD cable, is this braided shield. It's important for variable frequency drive applications that you have a shielded cable from the drive to the motor. It keeps noise out and it keeps it from radiating back to the CNC motion controller. And then to get this stuff apart, it's not that difficult, is I just take a pick and pick the braid apart a little bit at a time and you'll get it. And because I'm bench testing, I'm not going to make any of this permanent until it's in the cabinet. I left myself enough cable to make it in. Like that. And then I'm going to take and I'm going to twist the braid together. Okay, and in this cable we have 4 conductors. The green with the yellow is going to be ground, and then we've got black, red, blue. Those are going to be our current carrying conductors, or power conductors from the VFD to the motor. Let's go ahead and terminate. Okay, I've got some ring terminals to put on this wire. These are these are Klein crimpers. They do insulated and non-insulated. Okay, let me get a wrench for these. And we will be connecting, it says RST, to these right here. Any one of these. I'll probably put them right in here to keep the connectors away from the terminals. Black, red, blue, okay. Put our little wiring diagram back in the housing and see if we can get this put back together. All right, well, I can see there are my ways. I may not be able to get in there to drill and tap that. It's meant for a self-tapping screw and it doesn't come with one. So what I'm going to do is I'm going to go ahead and off camera, I'm going to drill tap and put this wire on there. I'll be right back with you. Okay, I've got the ground wire terminated down here on the motor frame. And we're all wired up in here for the 230 volts. We've got our drive. I've got an AC power cable here so we can wire up the drive. We've got our motor leads here coming from the motor compartment there. There's a quick start reference guide that is included with the GS1 drive. What I'd like to do is I want to run this motor directly from the operator panel. That is right here from the front of the AC drive to make sure the motor works. We can control the motor and then we'll fool around with some parameters and set acceleration, deceleration, and so forth, and then test those features. And I want to go through showing you how to set this up. I've done a couple of the GS series drives. I haven't done this little guy, this GS1. It's really small, which is nice and compact for this this Emco CNC lathe. So anyway, let's go ahead and get it wired up. Looks like for 120 volts, we're gonna go to L1 and L2. So here's L1, L2. So I'm gonna put black under L1. Gonna put white under L2. This is 120 volts, remember. And then here's our ground lug. So I'm going to put ground, our green, under our ground on the drive. Okay. And then it shows our motor going on T1, T2, and T3, and then chassis ground. So here's our motor. I will put black under T1. Give it a tug. I'm going to put red under T2. Blue under T3. And then our chassis ground, of course. Okay, this drive is set to factory default. So I'm going to go ahead and plug this into a 110 volt outlet. This little motor, when you're doing this, you're going to need the nameplate data off the motor. Primarily it's 230 volt, 60 hertz, half horsepower, 3,300 RPM, and it draws 1.8 volts at 230 volts. We're going to need that to program the VFD. So looking at this, there isn't anything else to set up. We are going to use the analog input. Okay, its factory default says factory programming is forward, stop, reverse, stop, D1, D2, we'll be using those. External fault, we won't be using that. Multi-speed, we won't be using that. We will be using the common signal, and we will be using AI, and we're using the common CM for the analog input. We will also be using, looks like R10 and R1 for drive fault or spindle fault to Acorn. Okay, now that we're powered up, we need to set some basic motor settings in the drive. On the quick card here, we need to set up those 0 parameters. And what they are is motor nameplate voltage, motor nameplate amps, motor base frequency, motor base RPM, and motor maximum RPM. So I'm checking on from the manufacturer to see how fast, what the max RPM is for this motor. It is an inverter duty motor, but they didn't tell me what its designed RPM, max RPM was for, so I'm checking on that. Okay, we're gonna go program enter, and it's 0. Program enter is 0. So the first to enter is nameplate voltage. So we hit enter, and it says 240. The nameplate voltage on this is 230 volts. So we're gonna drop that. Whoops. There it is right there. So we hit enter, automatically advances to 0.1. That's nameplate amps. We'll hit enter. Here it says 2.5. If we look at the nameplate amps here, it's 1.8 amps for 230 volts. So we're going to drop that. And we hit enter. Motor base frequency, it's going to be 60 hertz. That's what the motor base frequency is. So we'll hit enter. It says 60 already. Motor base RPM, and if I look at the label, it says 3,300. So we hit enter, and here it says 1750, so we're going to take it up to 3,300 RPM. Okay, there's 33, we hit enter. The next one says motor maximum RPM. Hit enter, it says 33, we're going to leave it at that right now. Let's go through the rest of these here. It says stop methods. So we're going to hit enter, and we're going to hit display, and we're going to increment up to the 1, which is acceleration time. We'll hit enter, which is 0, 0. Stop methods, ramp to a stop or coast to a stop. We're going to go ahead and ramp to a stop. That lets us use the deceleration time. Enter. 1-01 is acceleration time. So 10 seconds. Let's cut that way down so we don't have to wait 10 seconds for it to come up from 0 hertz to 60 hertz. I'm going to cut it down to, let's try 3 for now. We'll hit enter. Deceleration time is 30 seconds. Let's drop that. We should be able to do better than that. Freewheeling with no load. Let's try 3 seconds. Now, if either one of these values is set too low, the drive could fault. So keep that in mind. All right, we're gonna hit enter. All right. And then it says volt hertz settings. Enter. 200, general purpose, high starting torque, fan and pumps. The lathe really doesn't have much high starting torque. So the options are 0 general purpose, 1 high starting torque, 2 fans and pumps, and 3 custom. Let's see what we got. 0, let's just leave it at general for now. All right. The next one says manual torque boost, 0 to 10%. It says 0 right now. Let's leave that stuff alone for now. Enter. Next one here, it says source of command operation. Display 3, enter. And it says 0, it says operation determined by digital keypad. That's here. When we go to change these to digital inputs, it says, so 0 is operation determined by digital keypad. Number 1 is operation determined by external control terminals. Keypad stop is enabled, meaning the stop would still work. The next one, operation is determined by external control terminals. Keypad stop is disabled, meaning if you program everything from here, you can't shut it down at the keypad. Number 3, operation determined by RS485 interface. Same with 4, RS485 interface. One says keypad stop enabled. The other one says keypad stop disabled. So for now, we're going to leave it at 0 because we want to use the keypad. Goes into multifunction inputs. We'll test that later. So for now, let's just test what we've got. So we're going to go back to display. There's our hertz. And now we're going to go ahead and press start. So we're at 18 hertz. Okay, let's go ahead and use the keypad to start the motor. We'll press start. It's blinking here. There's a little dot blinking next to the stop, and we're at 0, so now we can crank it up. You can see it came up much faster. There's 60 hertz. Let's shut it down at that point. Okay, it stopped. And I think we had a 3-second stop and a 3-second start, I believe. 1001, 1002, 1003. That's about right. Now let's shut it down. 1001, 1002, 1003. That's about right. And there's no fault. We have no load on this motor. So anyway, you know, we just basically bench tested this motor that it works okay. The speed pot on the control works. Okay. So we know everything's good. So we're going to go ahead and stop it. Now I'm going to go ahead and unplug it, and then we're going to use the digital inputs for forward and reverse. It says it's pre-programmed for that, D1 and D2 using common, so that's what we're going to try first. Let me unplug the drive first. All right, I got a little jumper here, and we're going to be going from forward stop. We want DI1 and DI2. So let's go ahead and use use red for D1. Let's use green for D2. And we need a common. So let's go ahead and use, let's use the white for common. So that means white to red should be forward, white to green should be reverse. Let me put the motor up on its end for testing. I'll put a little piece of tape on there so you can see it run. Right now, black is not used. Theoretically, the way things should work, we've got to make one change because we're going to go from control panel to digital inputs. So let's go to this card here. It says source of operation, we're going to go from 0 to number 1, and we'll leave the stop enabled. In our case, it doesn't hurt anything. So let me power the drive up. We want to get to 300. So we hit program enter. Make sure you cycle to 3, and then you program enter. We're at 0. We hit enter, and the default is 0, and default is set to 0. We want to go operation determined by external control terminals. The keypad stop is enabled, so we want to switch this to 1. Enter. All right, let's go back to display, hertz. Now, here's our jumper. So white, we don't use black. So we're going to go white to red. I'm going to tip this down. So you can see I have red on D1, I have green on D2, and I have white on common. Okay, so I'm going to hit our white to red, which is on D1. That should be forward, and then white to green should be reversed. So let's watch our motor here. All right, white to red. All right, and the motor was spinning counterclockwise there. So now let's go green. So we went white to green, and our motor spinning clockwise. We know that our inputs are working on forward and reverse. So our next step now is we want to program the digital input to accept the analog input signal, and that's AI, analog input. That's our 0 to 10 volts that will be coming from Acorn. Before I connect it to Acorn, we're going to test it manually. So I'm going to use a battery on this one. Let's see, I got my wires loose there. I'm going to go to analog input, AI, not 10 volts. We do not use 10 volts. The analog signal supplied from Acorn, so we're going analog input. Okay. So there's analog input. Now we need to go ahead and look for source of command operation. We've got that. Source of frequency command right here. So we want to go to frequency determined by 0 to 10 volt input on AI terminals with the switch. So that's what we want. So we want to change this to 4. So we're going to hit program enter. And then we're going to go up to 4, program enter. And we want source of frequency command. Source of frequency command is 0. So we're going to hit enter, and it says 0. We want to change it to frequency determined by 0 to 10 volt input on AI terminals with switch. So we're going to change it to 2. 1, 2, enter. All right. Now I'm going to change this back to our display to hertz. So we're going to use a battery to simulate the input. We'll use a 1.5 volt battery. So let me grab one. Okay, we've got a simple 1.5 volt C cell here, and we've got a 9 volt battery here. Our common is going to be our white, and white is going to ground to the battery. This might be a little tricky. Is going to the right here. So positive is top, this is negative. So white's going to go down here. We want to energize red, so I'm going to put red on the common as well. You can see, you barely see that is blinking. And we want analog input, so we're going to touch the black. That's 1.5 volts. So that's putting a 1.5 volt signal to our drive. Okay, do it again. You see it running counterclockwise. Let's change that red to green. And we're going to touch our black. Now it's going clockwise, 9.7 hertz. Okay. Now that was 1.5 volt signal input. So let's go ahead and take our red and our white. I'm going to fold back to green for now. And here's our analog. So we're going to do the red and white. We're going to use a 9-volt battery, so we have a 9-volt signal in. So the small terminal on a 9-volt is positive. The large terminal is negative. So we're going to hold this to negative and our black to positive. So this battery might have more than 9 volts to it, but you see the frequency? 59.2 hertz. We almost get full speed capability by applying 9 volts to the analog input. Okay? So at that point, we know by using a battery and not connecting to Acorn, now we know that the drive is able to be commanded by the digital inputs, forward and reverse, and the analog input. So let's wire it up to Acorn, and let's let Acorn control all this stuff.